Energy absorbed by each molecule. A2 of a substance is 4.4 into 10 to the power of minus 19 joules we have given. How much energy we have given to this bond? To break this bond we have given how much energy? 4.4 into 10 to the power of minus 19 joules we have given to break this bond. But this molecule require how much energy? Only 4 into 10 to the power of minus 19 joules. Is it clear, everyone? To break the bond, it requires how much energy? 4 into 10 to the power of minus 19. But more than you are giving that. So how much your energy you are giving? Excess energy you are giving. The excess energy, the excess amount of energy is converted into kinetic energy. Suppose, let us assume, to break this bond, let us assume it requires 100 joules. All of you please stop writing and listen to me. To break this bond, I required 100 joules, right? To break this A and B, to break this bond, how much energy is required? Let us assume that is 100 joules. But you are giving 150 joules. How much energy you are giving? 150 joules of energy. But I required how much? Only 100. But the remaining the 50 joules, it is converted into kinetic energy of the molecules. Okay, because using of that 50 joules and the A and B get separated. Okay, so for to break this only 100 joule is required. The remaining 50 joules means 150 minus 100. How much it is? 50 joules, and these 50 joules are converted into kinetic energy. Similarly, here also same thing. Here also you have to do same thing. To break this bond, we require how much energy? Only 4 into 10 to the power of minus 19 joules we require. But you are giving how much energy to break this bond? 4.4 into 10 to the power of minus 19 joules you are giving. But we required only this much energy. 4 is there, here 4.4 is there. How much energy you are giving excess? 0.4. How much you are giving excess energy? 0.4 means the excess energy, that total energy minus required energy is equal to kinetic energy. So 4.4 minus 4 is how much? 0.4 into 10 to the power of minus 19 joules. This 0.4, how we can write this? This 0.4, how we can write this? 4 into 10 to the power of minus 20 joules, right? This is your answer. This is equal to kinetic energy. So kinetic energy is equal to total energy minus required energy. Okay, otherwise bond energy. Total energy minus bond energy per molecule. Okay, then you will get this kinetic energy. Kinetic energy equal to total energy minus bond energy per molecule. 4.4 into 10 power minus 19 minus 4 into 10 power minus 19. The difference is how much here? 0.4. The 10 power minus 19 is common, right? So the answer is 4 into 10 to the power of minus 20 joules. Ardhamavutunda? Yes. 0.4, how we can write this? 0.4 we can write as 4 into 10 power minus 1 and 10 power minus 19. If bases are equals, powers can be added. Minus 1 minus 19 becomes minus 20. Is it clear, everyone? Okay, so move on to the next question. But this is not correct answer. Why? Because this is kinetic energy per molecule. In the question they have asked for kinetic energy per atom. Okay, here we have how many atoms? A2 is there, right? How many atoms are there in A2? 2 atoms. Okay. So to get this kinetic energy per atom, what you have to do? The total energy by 2. 4 into 10 power minus 20 by 2. So how much it is? 2 into 10 to the power of minus 20 joules. And this is your correct answer. Okay, put a tick mark on D. If a gas expands at constant temperature, it indicates that. Okay, if gas expands at constant temperature, then what is its kinetic energy? Kinetic energy is directly proportional to temperature. Yes. If temperature remains constant, the kinetic energy also remains constant. Means there is no change in the kinetic energy. Means kinetic energy of the molecules remains same. So which one is matching your answer? A is matching. Volume occupied by one molecule of water. Okay, so now you see 6.023 into 10 to the power of 23 water molecules having weight is how much? 18 grams, which is equal to molecular weight of the water. Means 18 grams of water molecules, 18 grams of water. Okay, in 18 grams of water consists how many number of H2O molecules? How many number of H2O molecules? 6.023 into 10 to the power of 23 water molecules have the weight how much? 18 grams, which is equal to molecular weight of the water. Molecular weight of the water is how much? 2 hydrogens, 1 oxygen. Oxygen weight is 16. So 2 plus 16 is how much? 18. Okay. So 6.023 into 10 to the power of 23. This number is equal to molecular weight of the water. So which gives that 18 grams of water. Okay. So 18 grams of water consists how many number of water molecules? 6.023 into 10 to the power of 23. And also they given here the density of the water is 1 gram per ml. So what is the meaning of this? What is the meaning of this? 1 gram per ml means 1 ml of water weighs how much? 1 gram. 2 ml of water weighs 2 grams. 3 ml of water weighs
3 grams.
Like that 18 grams of water weighs 18 ml. How much? 18 ml. So how much volume? 18 ml of water. Means 18 ml of, in 18 ml of water, how many water molecules we have? 6.023 into 10 to the power of 23 water molecules we have, right? We need to find the volume occupied by one molecule of water. One molecule of water. Okay. So then this is 6.023 into 10 to the power of 23 water molecules occupies this much of volume, 18 ml of volume. Okay. This is H2O molecules. These are the H2O molecules. Okay. We need to find one molecule of water occupies how much volume? One molecule of water occupies how much volume? Okay, let us say this is X. Just you do the cross multiplication. Then how do you get this X value? Your X equal to 1 into 18 by 6.023 into 10 to the power of 23. Okay, so when you do this, you will get ml. So 6 how many times it is? 3 times. Let us assume this 6.023 as a 6. 18 by 6 enter. How much it is? 3. So into 10 power by 10 power 23 which is in the denominator. When you take it up, so it will become 3 into 10 to the power of minus 23 ml. So what is the X you got here? What is the X you will get here? 3 into 10 to the power of minus, what is that? 23 ml. And that means here one molecule of H2O occupies this much volume. This much volume means 3 into 10 to the power of minus 23 ml. 18 ml of water consists this many molecules, right? And 3 into 10 power minus 23 ml consists only one water molecule. Only one water molecule. Okay, the answer is 3 into 10 to the power of minus 23 ml, or ml we can write as centimeter cube also. 1 ml equal to 1 centimeter cube, right? Is it clear, everyone?
Yes, sir.
Van der Waals real gas acts as an ideal gas in which condition? Okay, real gas means there are so many attraction forces, repulsive forces are there. When gas molecules are close to each other, there is a chance of attraction forces and repulsive forces. Okay, so you make these gas molecules far from each other. Okay, for this, what are the conditions are favorable? When you increase the pressure, gas molecules come close to each other. We want to separate the gas molecule from each other. Okay, for this we need high temperature and low pressure. When you increase the temperature, gas molecules move very fastly and they move far from each other. Okay, when you decrease the pressure also, they move from each other. When you increase the pressure, they come close to each other. Okay, so what are the conditions favorable to Make the gas molecules separate or far from each other.
High temperature.
High temperature and low pressure. This is your answer.